Okay, we start. Let's start. All right. I'm not getting very many more customers today, so you're it. All right. So I thought I'd start today with a slightly interesting historical story. And the reason I'll mention this story is because at various points, all of the modeling notations, all of the devices we're going to learn for describing services, the interesting thing to keep at the back of your heads is that these can all be learned from data. Right? But to be able to learn these things, you need data variability. And I think I was mentioning this in the first lecture, that you need a lot of variations in what is happening to be able to learn interesting things. So remember, I was saying in the first lecture that one of the interesting applications of these techniques. So very good. I have more customers coming in. That's very good to see. Um, so I was told that I scared you all by mentioning exams yesterday. So then I will add a little caveat to what I said yesterday. The exam is going to be super easy, right? So just show up at 9:30 on Saturday morning, and super easy exam. It'll also be super easy for me to mark, right? So maybe that will inspire your friends to come and attend the lecture. Hmm? Short answer, short answer. Very, very short answers. Actually, I haven't even thought of what I'm going to set. I'll think on Friday evening or something like that, depending on what we cover by Friday, right? So I think the exam is a mere formality. I mean, because it's a course, because it is designed the way it is, there's a obligatory exam component, so I have to give it. If you're taking the course formally, you have to take it, that's about it. But I think ultimately, what I am interested in, as I said at the very beginning, is to get you all inspired and interested in this stuff. So if I can do that, and you don't do that great in the exam, who cares? I've achieved my goal. So I said I'll start the lecture today with a little story, right? So I said we've been talking off and on about machine learning, data science, because it's on every computer scientist's mind in some sense, right? But I was also saying that when you do research in, for example, medicine, in oncology, for example, there's an obligation for all doctors to follow the standard process model, right? The kinds of process models we talked about yesterday. So everybody follows the same process model, but then if you're trying to learn interesting stuff, you're saying what's to learn? There's no variability in the data. So go back to 1943. So this is a very interesting time in terms of medicine, right? So um, first antibiotics were being used in World War II. This is the middle of World War II, right? But for some difficult diseases like most cancers, the only thing that people knew how to do was cut the disease out. So surgery was the big thing. Chemotherapy was not really known at that time. So chemotherapy was not known, it was mainly surgery. And if you couldn't do surgery, you gave up. So there was not a lot of, if I'm a data scientist sitting in 1943, for me there's not a lot of interesting data because everybody's doing the same thing. Right? So if I want to learn from the data, what things work and what things don't work, I have nothing to go by because everybody's doing the same thing. But then something interesting happened. So this is the middle of World War II. This is Italy. And there's a town in Italy called Bari, which is on the coast, and there's a harbor. And by this time, the American and US militaries, the so-called allies, were moving up from the south of Italy. And Italy as a government had surrendered and the Germans had taken over, and so it was a fight between the Germans and the Americans and British. So at this point, Bari Harbor was under American and British control. It was a major supply point, lots of ships coming in, supplying their troops. So at some point, the Luftwaffe Air Force, right, they decided to do a mini Pearl Harbor kind of raid. They sent in their planes to bomb these American and British ships. And so this is a picture of one particular American ship burning. So this American ship was called the USS John Harvey. It's a very interesting story. So John Harvey was hit by these bombs from the Luftwaffe aircraft, and there was many other ships as well. Lots of soldiers died. But a very funny thing happened with this particular ship. To the embarrassment of the US government and the US military, so much so that they wanted to hide it. This particular ship was carrying something called mustard gas. Anybody heard of mustard gas? It was a chemical warfare agent first used in World War I. In the trench warfare of Western Europe, they used to use this gas. It was the most terrible chemical weapon because people would go blind, they would tear the skin. It was a terrible chemical to use, and they used to release this mass. Both sides used it. It was the most terrible thing to use. And by the time World War II came about, all the governments in the story were saying, we're very good, we don't use it. And to the embarrassment of the US government, they were found using, well, they were carrying it in that ship. That ship was full of mustard gas. So it got bombed, the mustard gas got released. So all these soldiers, mainly American soldiers and some British and some Italian civilians as well, they got hit by mustard gas. Now this was something the government wanted to keep secret. So at least for the US soldiers and the British military and so on, they quickly flew them out of there and flew them to the US and parked them there. And then some doctors started studying them. So these are mustard gas victims. There were also mustard gas victims in World War I. But with these mustard gas victims, they now were studying them pretty carefully. One of the things they found was that the mustard gas was killing their bone marrow. Now, killing the bone marrow is actually a kind of cure for lymphoma. For lymphoma, which is a kind of cancer of the lymphatic system, you want to kill the bone marrow. So doctors suddenly realized, hey, we have a medicine here. We have a therapeutic agent. Mustard gas, or a variant of it, can actually attack this cancer. And so we discovered the first chemotherapy drug. So that's very interesting, right? So if you think about this from the perspective of data science, what's happening? Careful scientific process, recording of data, curation of data, mining of data would never give us this. These unlikely episodes where you had a ship full of mustard gas getting bombed by the Germans and having sailors and soldiers affected by it, that gives you the insight that here's something that can really make a difference. So this was literally the story of the very first chemotherapy agent that people used. Mustard gas from a ship that was bombed. So what is that telling us? That there are limits to data science, right? Serious limits to data science. Okay, so having said that, I have a whole talk on data science in in cancer research, but I won't go into it right now. Kill this. Okay, so I think we were kind of here, right? So let's start from here. So we're just wrapping up the last few details of BPMN. Now, I would hope that you'll all go and then read up BPMN in some greater detail. There's some very good tutorials on the web that, they're tutorials that are very useful if you want to, learn BPMN in that bucket filling mode that I was talking about in the first lecture, where you learn every last detail. But I don't feel very inspired to teach in that mode. I mean, I would like you to, from my lectures, take away the really important bits of BPMN and go learn the details from these other tutorials on the web. So, so the last couple of things was that we were talking about the idea that there are managerial concepts in BPMN, right? So this is a modeling language which allows you to talk about organizational structures. So you have pools and you have lanes, right? So we saw that. But interestingly, one of the critiques of this, in my mind, is that you can only model flat organizational structures. So, the idea of a lane, right? You can say, okay, there is an organization, and under the organization there are smaller subunits, but that's it, right? So there isn't a hierarchical modeling of sub-lanes and sub-sub-lanes and so on. So organizational hierarchies cannot be modeled. So it's just a flat organization that can be modeled. And those pools, they describe B2B networks, right? So the idea that one business interacts with another business by sending messages, receiving messages, and so on and so forth. Right? So that's That's something that is useful. But again, B2B networks can also be hierarchical. And so the complexity of B2B networks cannot be modeled using the pool facility. So again, it's somewhat limiting, but it makes an attempt to do some managerial thinking in the context of what is essentially a IT flavored process modeling notation.
So B2C, business to customer, also can be.
Yeah, so a customer, as far as this pool concept is concerned, a customer is also an autonomous entity. So as long as it's an autonomous entity over which I have no control, it's a separate pool. Right. So if I'm modeling my interaction with you, we're separate pools. You can't order me, I can't order you, but I can request you, you can request me.
So there is just a B2B itself, not B2C.
So yeah, so let's not worry about B2B or B2C. It's basically interaction between autonomous entities versus entities where inside which there is the idea of being able to provide control, right? So those lanes.
If you have multiple profiles of customers, would we be using different pools or a single pool with different symbols?
Multiple profiles of customers. So I would do the following thing. So you're basically saying there are different types of customers. So what they do with the interaction with me is different, right? If that is the case, then I will model them as separate pools because the processes sitting inside those pools are different. But if everybody's doing the same thing, even if for some other reason I'm thinking of them as different customer types, I'll just model them as one pool.
Like for example, if I am an education entity and my customers, some of my customers are teachers and some are students. In that case, the kind of activity that they will be having with me will be the same, with minor differences.
As long as there are differences, it's worth modeling separately, right? So, if they're not worth modeling separately, then they are not different. That's basically it. But remember, there's another very important point that this raises with modeling, right? So, if I teach a class on modeling, people will say, "Sir, have I given the right answer?" So I can tell you if your model is syntactically incorrect. If I'm like a compiler for models, right? I can check and say, "Okay, you've got problems here." I can approximately say, "Yes, you've got the idea of the thing that you're trying to model," approximately. But is there one correct answer? There isn't, right? So for modeling, there are as many correct answers as there are people, right? You can literally model any single problem in many, many different ways. And that's a very interesting question because that begs the question. So, is there such a thing as a good model versus a bad model? Given that we know that, um, come and sit in the front. They're all keeping a safe distance. So yeah, so there isn't a single correct model. That was the point. So now there are these artifacts. Okay, so let me finish that story then. So I got a bit distracted. So is there such thing as if if I'm given a bunch of models which are all syntactically correct, which approximately say the same thing, but they're modeling it differently, is there such a thing as an optimal model, right? So in the conceptual models that software engineers look at, that question has not been adequately answered by the research community. It's an open question. But in the kinds of mathematical models that optimizers, operations research people look at, that question has been looked at in careful detail quite recently. And they're saying while I can take a bunch of functionally equivalent models, I might find that some are more efficient to compute than others. So the way in which you model actually does make a difference. But there's a very funny story in operations research, right? In operations research, the story is that uh, good modeling is a black art. You can't teach a person good modeling. It comes from within. So the which variables you choose, how you choose to write the relationships or constraints between them is, there is no science behind it. You just hope that you're doing the right thing. So it's kind of true for software modeling, for conceptual modeling, and indeed therefore the kinds of modeling we're talking about here as well. There are many ways of doing it. There isn't any scientific guideline that says this is the best way of doing it. But we know as a hunch that some models are better than others, even if they are functionally equivalent. Okay, so one of the other things you'll see in some process models, I think we have an example here perhaps. Yeah. So you have these data objects associated with other things, right? So that's a data object, and it's associated with this dashed line with either a task or a message or something or the other. So you can do that, and that's moderately interesting because it reveals a few things. Does it make a huge difference in terms of execution? It doesn't, but it's good for showing stuff. So you can look at that. So what have I done? Okay. So two important terms that we need to keep in mind. So if you're in this business, you will see these words used very frequently. And you often wonder why people pick these terms. I mean, they're sort of music and dance related, right? So orchestration, the idea of making an orchestra work in unison, right? So the idea that there's a conductor and the conductor says, okay, now you, the violin, start playing. Now you, the flute, start playing, right? So that's the metaphor, right? And so orchestration really is the idea that you're executing a bunch of actions or activities under the direction of a conductor. That conductor happens to be the process engine. So the process engine is the conductor. The process engine gives coordination commands. First you do this, then you do that, and so on. And people do it under command, right? So it's within an organization. So orchestration is a process description that sits within the boundaries of an organization. A process engine in one organization cannot issue commands to another organization. Now when you're talking about then multiple organizations, what's happening? No commands, right? But there are messages, requests and responses. Please do this. So now that they call choreography. Why? So the reason apparently is that when you think about the design of a dance program, when you see a ballet or some other dance performance with multiple dancers, there isn't a dance conductor standing around in front and saying, okay, you. Right? They don't do that. They just sort of decide a protocol amongst the dancers. First I'll do this, then and this is the cue for you to do this, and so on and so forth, right? So there is a inter-party protocol that the dancers follow. That is a choreography. So a choreography basically describes the protocol that businesses follow in their B2B interactions. I will send a purchase order, you will send a confirmation, I will send an invoice, you will send a payment, I will send a shipment, you will send a receipt, etc., right? So these kinds of protocols is what you would model in a choreography. So the software engineering people haven't yet seen UML, right? But if you have, in UML, interaction diagrams model choreographies in some sense. They're messages that go between objects, right? So that's a choreography. So in our setting, we have these messages that go between pools, right, in the BPMN model. So that's choreography. But it's interesting. So the idea that I draw messages back and forth is a pretty sort of restrictive way of describing a choreography, right? So it's literally a protocol. I mean, I'm sure you've heard the word protocol being used in other settings, right? So we kind of followed protocol on the first day of this Gyan course, right? So there was a little formal protocol that we followed. So I was escorted onto the stage by Professor Kamath and Professor Wag and so on and so forth. So we followed some ritualized rules. So it's the rules of courtesy and etiquette that, the flowers are given, I shake hands, I thank people, other people thank me, and so on and so forth, right? So we're following a protocol. So it's much the same with businesses, right? So there are some rules of engagement that they agree upon, and then they follow it. So that's a choreography, right? So it's kind of interesting, and people have started taking a look at this. How do these things evolve, right? How do choreographies evolve? And there are studies which involve evolutionary agents that somehow give some answers, right? So for example, in traffic, there is a there's a protocol that, if there's a car in front of me in another lane and that car wants to move into my lane, the car blinks to the left. I see the blinking lights that says I want to move to your lane. So I slow down, that's protocol, and let the other guy move into my lane. Right? So it's protocol. There are some agreed upon rules of engagement that we follow. But in B2B networks, there are some other interesting ways in which you can describe these protocols. So one way is to think about promises that organizations make to each other. So I don't know, you order something from Flipkart, right? So there's a lot of promises flying back and forth. Anybody order things from Flipkart, e-commerce stuff? You have, right? A lot of you have. Good. I like the backpacks those guys carry. You seen those backpacks? Massive square backpacks. Anyway, so I saw them for the first time last year when I was in India. I said, wow, what a backpack. But anyway, so you order something on an e-commerce site like Flipkart. So there are promises, right? So maybe you prepay, and Flipkart says, if you pay, I promise to deliver this good within this date, right? So there's a promise going there. Or you might do a pay on delivery. I don't know if they do that here, but you could say, please send me the goods. I promise to pay when it is delivered to me, right? So all kinds of business transactions involve lots of promises going back and forth. So there's a guy who's done a lot of work in this, and he argues that choreographies are best described using these promises. So there's a guy called Moninder Singh. He teaches at North Carolina State University. Look him up on the web. I know him well. He's a good guy to work with. So his idea of a commitment is a four-tuple. There is a debtor, D, a creditor, C. So somebody who makes the promise, somebody to whom the promise is made. So, the taxi driver says to me, sir, if you pay for your ride to the airport today, I will show up at 4 a.m. tomorrow and take you to the airport. So the debtor is the taxi driver. I am the creditor. The precondition is that, as the taxi driver said, if you pay for the airport ride, then the effect, I'll make true the effect, which is the effect is that I will be at the airport at 4 a.m. tomorrow morning. Right? So it's a promise. Somebody promises to somebody else that if this becomes true, I'll make that true. And this is a very powerful device. You can describe a lot of B2B interactions with just this little thing. And so these guys have done a lot of work with it. We are trying to extend it. So it's a very interesting way of thinking about it. So this is just to tell you that choreographies can be modeled in other ways, and they allow different kinds of analysis. So this idea of modeling promises is also one way of managing autonomous systems. So remember so one of the things we're saying is that process modeling kind of assumes that there is command and control. First you'll do this, then you'll do that, and so on and so forth. The alternative way of modeling a process is to say, do what you will, like a surgeon or a lawyer and so on. Do what you will as long as you don't break these rules. So I just specify the rules and I say then, as long as the rules are not violated, you can do whatever you like. So that's another way of managing a complex system, right? So, and achieving complex functionality. And one of the things we said yesterday was that, governments do that. Governments don't prescribe everything we do in our lives. They simply lay down some laws and say, do whatever you like as long as you don't break the laws. And as long as you're not breaking the laws and the laws are carefully designed, ultimately we get the right behavior from the people in society, in a country. And interestingly, a data science question that I have been playing with for a while is, how do laws evolve? How do the rules that govern behavior evolve? And one possible description of what might be going on is this. The government looks at, imagine that this could be the case. Actually, it is not explicitly the case, I think. The government looks at, so there's lots of behaviors, right? So like a data scientist, you can say, I can see lots of executions of society. It's doing lots of things. Some of them are good ones and some of them are bad ones. Some of them are desirable, some of them are undesirable. I filter out the undesirable ones. Just keep the good ones, the desirable ones. And then I say to myself, okay, so with these behaviors that I have logged, right, this is being done, that's being done, that's being done, and so on. What seems to be the rule that they're following? So in the happy behaviors, the good behaviors, what's a rule that I can guess, mine, learn, which they're following? Because if I made that rule a law, then everybody would be showing that good behavior, right? So I'll be pushing the whole of society towards the right behaviors by figuring out what the implicit rule is that the good behaviors seem to be displaying, right? So some dumb example is that I go to a city where there are traffic lights and I say, okay, traffic seems to move very freely, very smoothly here. What is it that they're doing? And after a lot of serious data mining and machine learning, I figure out, aha, they're following the traffic light rules. So then I impose traffic light rules across the country and suddenly everybody's traffic is moving smoothly. Right? So it's a bad example, but it gives you the idea of. So this is how laws evolve, right? So choreographies, right? So we talked about choreographies. Now one final critical comment about BPMN, right? So how good is it ultimately? So does it allow flexible behavior and exception handling? Not really, right? Not really, because it only allows you to encode some behaviors. And one of the things we said in the last lecture is that there is this really hard problem that comes from AI called the qualification problem, which says that it is impossible to write the perfect rule. And for the exact same reason, it is impossible to write the perfect plan, and therefore it is impossible to write the perfect process model. I'll give you an example. So we had a commercial research contract with a company in Australia that does back-end processing for financial services. So things like pension funds and so on. So we had to process model their processes, and a lot of their processes are forms driven. So one of the simplest processes was a change of address form comes from a customer. Customer simply telling the pension fund that, my address has changed. And so it comes in an envelope, somebody takes it out, sticks it on a clipboard beside a terminal, and then they type. They look at the form and they type stuff and they say, okay, now I've changed the address. Dead simple stuff. But there are complexities, right? So sometimes you get a form where a person provides a name but no old address. They provide an old address and new address but no name, right? So you give some of the data fields in the form but not all of them. Now what do you do in these cases? In general, if you think about the space of possible errors of this kind, if there are n data items, right? So this is old high school maths, right? N data items, I can miss 1, I can miss 2, I can miss 3. So what happens? You have n choose 1 plus n choose 2, NC1 plus NC2 plus NC3 all the way up to NCN. I'm sure some of you remember that expression, right? So yeah, you have that huge space of possibilities. So we asked this company, so what about these exceptions? So you have so many of these possible exceptions, what do you do? So they said, oh yeah, sometimes we get a missing old address and then we call up this guy. And sometimes we get a missing new address and we also call up the guy. Other things don't happen. So I said, so should we model them in the business process or should we not model them? They said, don't model them. So we were trying to do a careful job, right? We wanted to consider all possible exceptions for something as simple as just taking a form and entering it into a database. There are so many exceptions to consider, but we were advised not to bother about many. So we didn't, right? So we ignored those. So that's what people do, right? They ignore a lot of the exceptional situations and say, when it happens, we'll worry about it. It happens so infrequently that if it does happen, we will escalate it to some human who will take care of it. Otherwise, it remains at the process level. So you can do that. But then the question comes up, is this really a good thing? So BPMN only allows you to describe some ways of doing things, the ones that you can anticipate, the exceptions you can and want to anticipate, the others you don't. So how do you handle exceptions in general? So there is a general consensus. I think people are beginning to understand that BPMN is pretty deficient in managing exceptions. So that's one really important way in which you need to extend it. So the reality is that every process, in the clean world of a business analyst, An insurance claim handling process ends in two outcomes, right? The claim is accepted, the claim is rejected. In the real world, there is an infinite space of possible outcomes. I accept half the claim, I accept 1/3 of the claim, I do not accept the claim but give some compensation money. There's so many things that happen as outcomes. Can you model them all in a business process? Is it worth it? Is it feasible? So people are asking that question, and certainly BPMN is not so great in doing those kinds of things. That's for sure. So there, yeah?
Non-functional characteristics, there's always trade-off.
There's always a trade-off. That's very true. That's very true.
But the BPM,
So BPMN itself is not that great in handling non-functional aspects at all. So what other people have done and we have done is we have imposed other machinery on top of BPMN to assess the non-functional characteristics. And if I have time, I'll talk about it. It's kind of interesting. So let me give you one little example of what that means. Yes, so suppose I have this process model, right? And suppose I said each of those tasks, T1, T2, T3, T4, takes 1 hour. So what is the total processing time of this process? Okay, so 3. I totally agree, 3. Now let me change the story. Let me say that T2 takes 2 hours and T3 takes 3 hours. Now what is the total processing time of this process? T1 takes 1 hour, T4 takes 1 hour. How did you get that? So T1 is 1 plus 2 from T2 plus 1 from T4 is 4. Okay, but what if I'm going down the lower branch of the XOR? Then it is 1 plus 3 plus 1, 5. So is it 4 or is it 5? If you're the business analyst and your boss says, okay, you gave me a process model, now tell me its non-functional features. How long will this process take to execute? Your answer will be, well, actually sometimes 4 and sometimes 5. Yeah, on Mondays 4, on Tuesdays 5, something like that. What do you do, right? Yeah, so you're right. I mean, you can sometimes say minimum, maximum, best case, worst case. You're right. The other thing you can do is you can sometimes use data. You can say, okay, so 30% of my flows go on the upper path, 70% on the lower path. So I do a simple probabilistic expression and say, okay, the expected value based on this probability, right? Or I can get some expert to come and tell me those probabilities. What is the probability of taking one branch? What is the probability of taking the other branch, right? Now the other interesting question, now change the XOR in the gateway to a plus and, right? Now what's going on? So now we are doing both those flows in parallel, right? So, but the interesting thing is that I don't know if they're being done exactly in parallel or they're just being interleaved in different ways. Maybe T2 first then T3 or T3 first then T2, right? If I change the X to a plus, right? So it's an AND gateway now. So what happens now? So 1 hour for T1, then 2 hours for T2 and 3 hours for T3, right? So if they're happening exactly parallelly, like we were showing yesterday on the overlapping task durations, then okay, the total time that those two parallel branches is the bigger of the two numbers, right? So it's 3, and then 1 for T4. So that's easy. But what if they're not exactly overlapping? Then I have no idea. Right? I have absolutely no idea how long it will take. You can again offer some maximums and minimums and then stop there, right? Yeah. Yeah. I mean, even the maximums and minimums are tricky, right? Because you.
Technically, it can be infinite amount of times.
That's right. Yeah.
If you are starting time, like not instantaneous after the last previous process.
That's right.
Technically, it can be infinite amount of time.
But you can. So what we just did was an exercise in non-functional assessment of a process model, right? This is it. So I can do that for time. I can do that for cost. It's all these things. Okay. So back to where we were. So BPMN, we agreed, was pretty bad for flexible behaviors and exception handling. One of the other interesting things is that people often do this in real life, right? I need to go home. I have three different options, right? I can call a taxi, I can get into a bus, or I can walk. So depending on the objectives I have, my objective functions, my optimization functions, I will make a different choice. So now this is a kind of choice gateway, right? Where I'm saying, if it's a rainy day, I will probably catch a taxi. If it is a nice, pleasant day, I might actually walk. If it is a day when I want to save money, I will take the bus, right? So this is the kind of decision logic that BPMN doesn't support. BPMN supports XOR based on some condition. If you accept it, go this way. If rejected, go that way. But the kind of decision logic where you're sort of saying, okay, I have multiple optional paths. I can assess these paths based on their non-functional features, and then based on that assessment, I'll make a choice. That kind of gateway BPMN doesn't have. So you could introduce one. You could write a paper saying, I think BPMN should have a new kind of gateway. We haven't written the paper, but it could be written. It's a nice idea, right? So it's not so much worst case, it's a non-functional gateway. It's basically a point where you're saying, now at this point in the process, you look at the future, you make some predictions about the performance of the process in the future, and based on those predictions, you make a choice on which path you're going to go on.
Exploring all possible paths will not lead to.
Yeah, so all possible paths, that's the interesting thing, right? If in a BPMN setting, all possible paths are modeled for you already, they're there. You're simply saying, okay, which of these do I choose now? So you make some predictions about the performance of each of the possible paths that are already modeled, and you say, okay, I'll pick this one. But you're making a prediction, you can't be sure.
Then most of your decision logic is basically comes down to zeros and ones, right? You can
So a lot of this is Boolean, but you can now make interesting predictions, right? You can say, I look at the past data and I look at the alternative paths and I pick the one that looks like it's, my predictive machinery is predicting that it will perform best, so I pick it, right? You can do things of that sort. The other interesting question we are going to start answering today. The question is, in BPMN, if I get to a certain point in a process and I ask the question, what's happened up to here? Right? So I take that old process example. So I've reached up to here, right? Let's say. So I'm having a conversation with the business analyst who wrote this model. So I'm saying, okay, so if I get up to here in the process, what's happened? If you're the business analyst, what answer can you give me? Yeah, T1 and T3 are completed. Is that very interesting information for me? I am actually asking, so suppose this is a clinical process, right? And I'm a doctor and I'm asking, okay, so if I've done medical intervention T1 and medical intervention T3 to a patient, what's the patient looking like now? Predictively speaking. All I'm saying is that I gave the patient this pill and I gave the patient that pill. Do I know what the patient, how the patient responded to it, or all the details? I don't, right? So BPMN is not very good at answering these questions. What's happened up to this point? I'm talking about semantics. So all I can do by way of an answer to that question is offer some procedure names. I'll say, okay, I executed procedure called T1 and then I executed procedure called T3. That's it. I don't know what else has happened. So if you want to understand the impact of executing procedure T1, that's your problem. And you have to then combine it with the impact of executing procedure T3. That's also your problem. I'm not saying anything about it. I'll simply give you the names of the procedures I've done so far. T1 and T3. So that's not very good advice, right? It's not very good feedback. You want more information. So in fact, the next thing we'll do is we'll try to understand how to get that kind of information in easy ways from a process model. So it's a layer on top of BPMN that we will talk about that allows you to do that. And later on, we will talk about how you can even mine that layer from data, which is very interesting. I hope I get to this point.
Real-time constraint comes in. Critical applications, say critical applications, like big applications, the time aspect very important. Time constraint comes in.
Yes. And those kinds of questions are therefore even more important in those real-time applications, right? So how long did it take to achieve this outcome, right? And things of that sort. So yeah, and for those kinds of questions, BPMN is not very good in providing answers at all. Right? So, all right, so now we have done this, we have done this, we have done this. So now we'll move into this whole new thing called service modeling. So remember we talked about the idea that there is process modeling and there's service modeling. So, and I told you the story of how people can get tied up in knots about what's a process and what's a service. So for the time being, we are saying that service is the idea that encapsulates all the functionality. It sits on top, and inside it is the process, right? So let's take that kind of a view. But it almost doesn't matter. So what should a service model contain? So now remember, what is a service again? We've talked about this informally. A service is a piece of outsourced functionality. It can be even internal outsourcing in an organization, right? So, for example, in my university, the functionality of maintaining the lawns around the building where my lab is outsourced internally by my faculty to another entity called the Facilities Management Division. Those guys send the guys with lawnmowers and mow the lawn, right? So this is internal outsourcing. So within the same organization, you're also outsourcing. So there are services being offered inside an organization as well. So we're talking about this idea that I want to model these outsourced functionalities. How do I model them? So the first thing that you would say is, I want to get a description of that functionality, right? What is it that I'm outsourcing? So that must be part of the service model. I need information on how to invoke the service. So there's a lot of work done on that. So there's a big literature on web services where you talk about, so there are these languages called WSDL and so on, which provide that low-level detail that says that if you want to invoke this web service, you need to call this address at that port, and then the data format in which it will accept input is this, and the data format in which it will produce output is this. Have any of you ever used a web service? Or have you ever seen one? Tell me again. Is it a web service? Yes, you can set it up as a web service, right? So I'll tell you the web services I have used. So a lot of weather bureaus, right, meteorological departments will offer, maybe the government meteorological bureau does it here, a web service. What is the weather like in Panjim right now, right? So it's a web service. You get a input, you invoke the web service in a certain format that says, okay, I want the temperature for Panjim on this date, and you get an output in a certain format, right? Another web service I have used in Australia, there's a very useful web service. Australia Post has a web service which you can use to verify that a certain postal address is a correct address. Somebody gives you a postal address and they say the wrong thing. So the idea is that with this web service, you are asking Australia Post, here's an address, here's a postal address, is this a valid address? So you send that input, you get a yes/no answer as output. That's also a very powerful one, and almost every organization uses it. So if you're signing up for a mobile phone account or an electricity account or whatever, you provide your address. The first thing the company does online is it uses Australia Post web service to verify that this is in fact a valid address, and then they'll say, okay, continue. So these are web services, right? So people use these all the time. And so WSDL, and so these are some of the standards you use for describing the web services, for invoking the web services, and UDDI is a standard for describing these service directories. Right? So I'm not going to go into them because they're very low level. You can look them up. They're described in XML, and they basically describe data formats and ports and so on and so forth. Not hugely exciting. But again, what do I want to use to describe a service? How do I describe a service? So the one thing that I do is I describe service functionality, right? So I say, okay, what does a service do? So I need to describe that to model the service. How do I invoke? We just talked about. And then the non-functional qualities or quality of service factors, right? So how long will Australia Post take to give me an answer to the question, is this a valid address? It's a useful service for me if it takes a very short period of time, a few seconds. But if Australia Post says, okay, you submit your application in triplicate and in 3 months' time we will get back to you, then I will say it's not a useful service for me. So the non-functional characteristics of the service, or the QoS, quality of service characteristics of the web service, are really important, right? So I will base my choice of whether to use a web service or I need any service based on the quality of service, right? And so it is that you know that, did this happen here with pizza companies? They used to promise that if you order a pizza, we will deliver in 30 minutes. Did that ever happen here? They did, right? So a lot of people tried to risk their lives riding their motorcycles to your address to get the pizza to you in time to meet the 30-minute deadline, right? So this sort of thing goes on. So that's a quality of service guarantee. So the pizza company is saying, buy from me because I guarantee that in 30 minutes I'll have your pizza at your doorstep, and if I don't, then I'll give you a refund. Right? So it's one way you build business, by offering a really interesting and appealing quality of service guarantee to the customer. So these things are very important, right? The non-functional guarantees that a service offers. So these things we need to take care of and model. So there are a bunch of semantic web service modeling languages that exist. OWL-S is an extension of a very famous semantic web ontology language, right? Ontology web language, OWL. So OWL-S is the services extension to that language. WSMO is a standard that was developed in Europe. So for a while, OWL-S and WSMO, WSMO, were competing. They're much the same. WSDL-S is a semantic extension of this low-level service description language. Most of these fundamentally describe four things. They describe what inputs the service takes, what outputs it produces, what preconditions must be true, and what effects are made true. So the first thing you need to think about is, now you're saying there is an input and there is a precondition. There is an output and there is an effect. How do these things differ? Isn't the input also a precondition? Isn't a precondition also an input? Isn't the output also an effect? Isn't an effect also an output? Is it? What is the relationship between them? So think now, what is a precondition? A precondition is some condition in the context, in the domain of that service, that must be true for me to execute the service. Yes. Or for me to give a lecture, there is a precondition for me to offer that service. There must be electric power supply in this hall. Right? It's a precondition. If there is no electric power supply, I cannot offer my service. Right? It's a precondition. Is it an input? Not really. If I think of my lecture as a service, what is an input to this service? A little bit of the feedback you're giving me, right? So I may be modifying my service based on that input. You're telling me I find this more interesting, that less interesting, so that's maybe an input. What is the output of this service? The stuff I'm talking and the slides I'm putting up and so on, right? That's the output. What is the effect? Yeah, so what am I achieving by way of effect? Hopefully learning, inspiration, knowledge, those things, right? So there are inputs and there are outputs, there are preconditions and there are effects. And they're actually different beasts, right? So, but most of these standards, they talk about modeling these four things. And that's pretty good, because with these four things, you know quite a bit about a service. You more or less know the wrapper of the service. You're basically saying it's a box, it does these things for me. I don't know what's happening inside the box, but I know that if I give this input, I'll get this output. It'll execute if these preconditions are true, and when it has finished executing, those post-conditions or effects will be true. So I know these things. So I know quite a bit about the external interface of this box. Inside the box, I don't know much, right? So, now what we'll try and do is ask the question, so a service is a service, right? So, I used to have these debates, what's the difference between a computational service and a business service? What is the difference between a web service and a business service? Should I treat them as different things? And my position has always been that I shouldn't. They're just services. A service is a service, right? Some things are slightly more important in a business service. For example, the format of the input sometimes is not important. So when I use a taxi service, I can call the taxi and in an unformatted fashion provide some details about where I want to go, where I need to be picked up from, what time, etc. But for some other taxi services, they might give me a formatted input for thing, right? They might say, go to the web, fill out our web form, and then the taxi will be there. So then the taxi service, which is a business service, looks a lot like a web service because it's got a standard format for its input. So ultimately, my position is that you shouldn't distinguish the two things. So what we'll try and do is now talk about a language which combines elements of business services and web services, computational services, and ultimately they all belong to the right places. So they really are part of the same continuum. So we'll see what that looks like.
So business services that you said, you gave an example. We can write another layer that converts this informal description to specified format, and then you can both the things as the same.
Say it again. So you consider layers?
No, what I'm saying is business service, as you said, like you can have a formal input scenario or an informal one.
Yeah.
So you can just create a layer on top of
which takes the informal and turns it into formal. You could certainly. Yeah. So I think in the end, those are not really game-changing distinctions between a web service and a business service. They ultimately outsource functionality. They will do things for you, given the right input, given the right preconditions. Right. That's it. So here's a description of a language. It's pretty simple. It looks crummy, but it's actually very simple. So this is called the BSRL, the Business Service Representation Language. It's one of those things that are intended to allow this full modeling of all of the complexity of a service. So it's very easy to read, and I'll read through most of it for you, and then you can figure things out. So this is a service description of a particular service. We have an ID for the service. The first thing that we write down is a goal. So what goal does this service achieve? Which is an interesting question that you often don't think about, right? So what goal does this service help you achieve, right? So you describe that. Then you describe the preconditions. For this service to be invoked, these things must be true. Right? If I am a surgeon offering a service that I perform cardiovascular surgery, I have a precondition for my service. I have a precondition that says that the patient that I'm going to perform surgery on has been prepped for surgery. So there's a whole complex medical procedure, right? We made reference to it in some examples. You lower blood sugar, lower blood pressure, do this, do that, and then the patient has been prepared for surgery. And I, the surgeon offering the surgical service, will say, this is a precondition. If the patient is prepared for surgery, then I will perform surgery, otherwise I won't. It's a precondition. Post-conditions, right? Things that become true. So after the surgery has been performed, it will be the case that a valve in the heart will have been replaced. That's a post-condition, right? After the surgery has been performed, it will be the case that the appendix has been removed, or the tonsil has been removed, or something, whatever it is, right? It's a post-condition, the effects achieved by the service. And now we'll talk about assumptions. So we'll come to assumptions in a separate slide. There are inputs and there are outputs. That's the standard one we talked about. And then let's talk about the rest separately.
Maybe there are more than one preconditions.
Okay.
Preconditions, you have a single descriptive tag. Is there a possible way of making distinction between more than one preconditions?
Distinguishing between preconditions. So it's an interesting one. This is a question in logic, right? So in logic, I can say that I want P to be true, and I want Q to be true. So P is one precondition, Q is another precondition. But any logician will tell you that that's the same as saying that precondition P and Q must be true. It's just the same thing. There's no great value in distinguishing them, right? So it's just one statement of a condition that must be true. So what's new and interesting in what we looked at? We looked at a few things. Goals, which are new and unusual, assumptions, resources, and quality of service factors. So let's talk about goals first. So what is a goal? So a goal is a description of a state of affairs that we want to achieve. So there is a big literature in software engineering on goal modeling. And this literature started in the 80s. So until then, the idea was, so this came in the requirements engineering space initially. So the original idea was that you describe a system at a high level abstractly by writing down the functional requirements, the non-functional requirements, and so on. But then people said, that's not as interesting as answering the question, what goals does the system help me achieve? So I can write the functional requirements of a system that says, this system must take as input two numbers and produce as output the sum of these two numbers. It's a very functional requirement specification. But that doesn't help me understand what's this system going to be used for. So later on somebody tells me, this system is actually going to be used on in the in-flight avionics system of a fighter aircraft. And suddenly I have a whole lot of additional information, right? So I have some understanding of the goal that this system will help achieve. So it's probably going to be used in computing trajectories for missiles or incoming aircraft or whatever, right? So now that's far more interesting information than simply saying, okay, give me a system that adds two numbers. So in a similar sense, I do this exercise with students when I teach requirements engineering. So on campus at the University of Wollongong, we have a student information system. So that student information system, if you were writing the requirements for that system, you could write it in two ways. You could say, this system must be able to retrieve, given the student's ID number, the name and the address and the permanent parent's address and so on and so forth for each student. Given the student's ID number, it should retrieve the fees owed by the student, the marks received by the student, library fines, this, that, and the other, right? So I can tell it in those terms. But more importantly, at a higher level, there are goals that the system should help us achieve, right? So this system is about helping students achieve the goal of seamless interaction with the university. That's a goal, right? It's a much more interesting thing to describe than some low-level stuff about what the system does. So the argument in requirements engineering is start with the goals. What goals does the system help you achieve? And then go down to the level of, low-level requirements which say things at that level. The classic example a lot of these papers in this space use is, I'm writing the code for a system that controls a train. And there's a train IT-based system that controls train doors and so on and so forth. So the goal I have is achieve safe transit for passengers. And it is refined later on to a lower level requirement which says that the doors of the compartment must stay shut until the train has pulled into a platform and has come to a complete stop. That's a low level requirement. The high level goal is achieve safe transit for passengers. Right. So the idea is that it's interesting to start from that high level goal rather than the low level requirement. Right, so that's a goal. And so there's a big literature that says, we need to do stuff with goals. In fact, we do a lot of work with goals. And one of the most interesting challenges that people in BPMN type settings or the business process management community face, and we've offered some solutions to it, is I look at a process and I want to answer the question, what goal does it satisfy for me? What's it good for? And often that answer is not very easy to come by. Right? So why am I doing this? So I am the CEO of a large company and I find that inside the process repository, it's very interesting. Some organizations maintain repositories of process models. In Australia, I have seen two very large financial institutions and the kinds of process model repositories they maintain. the largest and the second largest financial services institutions. The largest one maintains a process repository of 6,000 BPMN process models. So they manage 6,000 distinct processes. The second largest one, and you'd say this is kind of funny, the second largest one manages 6. 6 versus 6,000. So you'd say, go figure why. And it's not like the one that does 6 is doing any significantly worse than the company that does 6,000. It is doing a little bit worse. It's number 2. The guys that do 6,000 are number 1. But it's interesting, right? So some organizations are very process oriented. They are very careful in documenting their processes, managing their processes and so on. Others almost don't care. So, any business process can be reduced to one single process design. You know what that is? Receive a problem request, open the problem, solve the problem, close the problem. You have a process, right? It fits everything. Surgical process, insurance process, whatever, it's the same model. So and once I actually sarcastically asked this guy from this second largest organization, is this, why don't you just use one process? Then you don't need 6, then you can just do with 1. Because sometimes that works better than the other one, yeah. That's right. It's time for our tea, 3:45. So class, we are starting tomorrow a little bit early, 15 minutes early. 2:15 instead of 2:30. And we are finishing 15 minutes early also, 4:45 instead of 5 o'clock. One more time, that exam that you should not be scared of, right? That exam, 9 o'clock in the morning, I said, and a lot of people complained bitterly. So 9:30 in the morning, are you still complaining? Hey? Say it again? See, there is a little problem, and that is that I have to mark all your exams before I go to the airport, and I have to go to the airport at 2 o'clock. So I have to work backwards from there. So I should allow at least 2.5 hours for marking, which means the exam must finish at 11:30. So is it really difficult to come at 9:30? Your colleague next to you, even as you're going like this, saying yes, he is saying this.
They can do it always, right? There is a way out. That they will reach.
You'll manage? I have an alternative, which is that on Friday, after the Friday lecture, we stay late and write the exam. How about that? 5 to 7. Professor Bhaskar, what do you think? So Friday 5 to 7. It's up to them, right? What? Saturday. So you're agreeing to 9 o'clock? 9:30. Okay. It's a complex bargaining process. Okay, all right. Okay, 9:30 it is. So 9:30 to 11:30, right? We'll do the exam. All right, so we were talking about goals, right? So we were saying that by describing the goals, we have a very easy way of answering the question, why am I doing this? And that's a very important answer if you are in the business of saying, I might have to keep some things and drop some things, right? So for example, if I want to say, I can only keep 2 screens, or I can only keep 1 screen on the stage, right? And there is one screen that has a poster for this course and another screen which is the projector screen. Now, suppose, in our context it's very obvious that if I have to give up one screen, I'll give up the poster screen, right? But for some other setting, it might be the case that you don't know why you have a certain artifact. So this is very common in software life cycles. You're looking at an artifact, you're saying, I have to drop one of these guys, which one should I drop? Now, if I know what goal is associated with each artifact, then I know which one's more important, which one's less important. So the answer, so this is often called the rationale, the design rationale problem. The answer to the question why, right? Why do I have this? So if I ask that question of the poster art screen, I will say, I have it for advertising this course. Why, right? And if I answer the question for the projector screen, the answer to the why question is because it helps me achieve the goal of delivering the course. Now I'm saying I have two goals here, advertising the course and delivering the course. At this point in time, which one's more important? Delivering the course is more important. So we can get rid of the other screen, right? So things of that sort. So in general, the idea of attaching goals to artifacts is really important. That idea goes even further, which we have tried in a project that involved, amongst other things, those days there was Infosys Labs. Now that doesn't exist anymore. The idea of strategic alignment. So companies have strategies and companies have assets. So the assets could be physical assets. We own chairs and tables and computers and buildings, but there are also knowledge assets, right? We know how to do certain things, know-how. We know the process design for doing this. We have the full organizational knowledge about how to execute complex software projects and so on. So now the question is, if I can attach each of these assets to the strategy it helps me achieve, then again I can do the same exercise. Which one's more important for me? I have to invest a certain amount of money in improving certain assets. Which ones should I improve? Which ones are more important strategically? So goals, strategies, these kinds of things are really important because they help you answer those questions. Which is more important to invest in? Which is more important to retain? And so on. So now then, coming back to a more technical level, what is a goal? So in the current literature, there are really three kinds of goals that people talk about. So one is an achievement goal. So it says achieve a certain condition. So that's like saying, a certain mobile phone company says, our goal is to achieve a state of affairs where we are the market leaders for mobile phones. It's an achievement goal. We want to achieve this goal. There is another kind of goal which is a maintain goal. So the goal of a doctor is to maintain the health of his or her patients. The third one is an avoidance goal. So this is very commonly done, this maintain and avoid. So avoidance is very commonly done in formal methods where they call them safety and liveness conditions. So an avoidance goal basically says, it is my goal to avoid a situation where the nuclear reactor heats past 120 degrees Celsius. That is my goal. So the reactor control system has a goal, and one of its goals is to make sure that the temperature never goes beyond 120 degrees Celsius. That's an avoid goal. So achieve, maintain, avoid. But they are not enough, right? So sometimes, suppose I gave an example, you're having a school play on a stage, and at some point you want to simulate the effect for thunder or lightning, strobe lights, right? Lights going on and off. So some kid is standing behind the stage, and his job is to take the light switch and go on, off, on, off, on, off, right? So I say that's your goal. Your goal is to, every half a second, flick it on, flick it off, flick it on, flick it off. Is that an achievement goal? No. Is it a maintain goal? No. Is it a avoid goal? No. It's something else. It's a procedural goal, right? So sometimes goals are just procedures. So essentially, these other goals are basically abstractions of procedures that sit behind them. There is a procedure or a process that helps me achieve a condition. There is a process that helps me maintain a condition. There is a process that helps me avoid a condition. And sometimes there is just a process, and I cannot describe it in any more abstract terms. So the process for flicking the light on and off is just a process. I can use some other words and say, okay, achieve maintain a condition of strobe light-like effects or something. I can use those words. But ultimately, some procedures are just procedures, right? So, but they are goals. So we can talk about goals using this kind of a vocabulary. Then the question comes up: how do you write goals? So, in software engineering, again, some goals are written in natural language, some are written in things like XML and so on, and sometimes, and most interestingly, in the research literature, they are written in logic. And what kinds of logics? They're the simple ones, like first order logic and so on. So, in first order logic, you describe static worlds. Then you have temporal logic, right, where you describe dynamic worlds, where you're saying, okay, states are changing over time, and I describe a sequence of states, not just one state, but a whole sequence of them. Anybody ever seen temporal logic here? No? Okay. So, very important device used in software engineering formal methods particularly. So, it is temporal logic is used for analyzing the behavior of software systems, right? So whenever you are in behavior modeling or analyzing behavior, you cannot stick to single state descriptions of behavior, right? So a system does not, you cannot describe the behavior of a system by saying, okay, here's a state. Because the behavior of a system involves many states. It behaves, it does stuff, right? So it goes from state to state to state. So a state transition machine, for example, is one way of describing the behavior of a system. And those state transition models, in fact, provide the semantics for temporal logics. So that's another way in which you write down goals. And then there are other more interesting logics. Dynamic logic is used heavily for semantics of programming languages. Non-monotonic logic for dealing with situations where you have incomplete knowledge. So there are all these logics that are used for describing goals. So just to let you know, I'm not expecting you to learn these today or in this week. So now we start talking about this idea that, so what's interesting in this business service modeling language? So we have preconditions, we have postconditions. Preconditions are things that must be true at the start of the service, when the service is invoked. Postconditions are made true by the execution of the service, right? And then there are these things called assumptions. So assumptions are very funny things. So suppose I come to an agreement with some house painters that they will paint my living room. So I say, okay, can you paint my living room yellow? So we come to an agreement, they will take 3 days to do it. I will pay them a certain amount of money at the end of the project when the room is painted. And the painters start painting, right? I've paid them no money yet. So think about the story from the perspective of the service provider, here the painting service, the painter guy. So the painter is saying, I am doing this work, hard work of painting the wall, on the assumption that the client is going to pay. Right? But if for some reason I have evidence to believe that the client is not going to pay, I will stop painting. Right? So think about an assumption. How do I model it now? Is it a separate thing or is it like a precondition? So can I write a precondition that says, the client must pay? I can't, because the client is not paying at the start of the service. The client will pay at the end of the delivery of that service, right? So I can't say, this is a precondition. So it's not a precondition, it's certainly not a postcondition. So it's some other beast, right? So an assumption is one of those things where you're saying, it's a condition whose truth I cannot check. When the service starts and possibly during the course of delivering the service, I cannot check the truth of this condition. But if at any point in time I find that it is false, then all bets are off. The service no longer needs to be delivered, my contract is null and void. So now any real contract, and you can look at your insurance contract if you have one, there's always a clause that's called force majeure. You see that word at the bottom. So force majeure is a legal concept which basically says that a contract is valid only on the assumption that during the life of this contract there is no natural disaster, no act of war, or no act of terror. So it's very commonly done in contracts that you put these assumptions in there. I will cover you as an insurer provided I can make these assumptions. So what is the insurer saying? If there is an act of war, sorry, my insurance cover does not hold anymore, right? But again, I cannot make that a precondition. I cannot say, okay, before the insurance contract period starts, let's check and make sure that there will be no act of war for the next 1 year. Who's to tell? Maybe there will. So the truth of this condition you cannot check at the beginning. And maybe you can never check. But if at some point the assumption is found to be false, and you find that there is a war going on, say, okay, contract is off. So that's an assumption. So it's a very interesting thing that is really critical to modeling a service. Now think about it. Any business contract is actually two service models stuck together. So suppose I had a contract with my house painter. Most times you don't with the house painter, but if you did, right, you sign a document, both of you, saying this is the conditions under which the house is going to be painted. There's really, the service is actually a co-production. I will tell the painter which walls to paint, what color, what style, and so on and so forth. I will pay the painter. The painter will do the painting. So the contract is really two service models stuck together. The painter's service model, where it makes some assumptions like you're going to pay me when I'm finished, and my service model, where I'm saying, okay, so if you, so there's a promise I'm making that if you finish painting those walls in the right colors in the right way, I will pay you. So that's a very interesting picture, right? So service modeling is about describing contracts. So, and a contract is basically composed of two halves, the client and the provider service models. And mind you, this idea of contract modeling is now very important. So a lot of people are working on electronic contracts, the monitoring of electronic contracts, and so on and so forth. There are complex logical languages for describing contracts that are coming up. So for example, one language allows you to describe what are called reparation chains, which says in the contract, I promise to do A, but if I fail to do that, then I promise to do B. And if I fail to do that, then I promise to do C, and so on. There's a whole chain of these. I'll give you an example. So last year I was flying to Germany and then Austria for some business. So I landed from Sydney, I landed in Frankfurt on an early morning, and after I came out of the plane, suddenly I found that Lufthansa was on strike. So this is a real story. So all international flights of Lufthansa were cancelled. Anything out of Germany to any other country. I had a connecting flight from Frankfurt to Vienna in Austria. And I wanted to get there by late afternoon because I had some meetings. So I thought, okay, I'm going to have to cancel my meetings because I'm not going to get there. So I stood in a long queue with a lot of other people in a similar situation. And then I realized what Lufthansa was doing. They were doing very interesting things. They were working through one of these reparation chains. So Lufthansa is basically saying, okay, I promise to fly you from Frankfurt to wherever. Now you are a business traveler. So to me they said this, we promise to fly you from Frankfurt to Vienna. So our aircraft will not fly there today. What we will do instead is we will put you on an Austrian Airlines flight. And so this is I promise to do A, but if I can't, I'll do B. So the B is putting me on an Austrian Airlines flight. As it turns out, from my perspective, it was really good because I actually arrived in Vienna before I was scheduled to arrive on the Lufthansa flight. My baggage arrived, and so I was really happy. So I had nothing to complain about. They were doing other things with other people. So for some people, they were saying, okay, so you're on holiday, right? So we'll give you a first-class train ticket. And some people, they were saying, we'll give you a first-class train ticket and we'll give you 3 nights free in a hotel. So they're basically saying, we made a promise to you, but failing which, we will give you a different thing. But interestingly, the reparation, the compensation, right? So in effect, the Austrian Airlines flight for me was a compensation for not being able to offer the original Lufthansa flight. So the reparation was making reference to the goals of the customer. So they were aware of the fact that my goal was I was a business traveler, I had a meeting to attend. So they designed a reparation that helped me achieve my goal. The holiday maker was in no hurry to get wherever. They said, okay, if you give me a nice first-class train ticket and a couple of nights in a nice hotel, it's good for me, I'm a holiday maker. So with reference to their goals, they offered a different reparation. So this is how you can compute and execute and monitor complex contracts. So again, as I was saying, computation and management are getting mixed up in interesting ways. This is another way in which it's getting mixed up with contracts, electronic contracts, monitoring of contracts, the computation of reparations or compensations, and so on and so forth. Right? And so in some cases, of course, Lufthansa was saying, we can't do anything for you, we'll give you money. So I promise to do A, failing which I promise to do B, failing which I promise to give you money. So this is again those kinds of logical reasoning that is applied. Okay, so back to assumptions. So we understand assumptions, right? So this is another interesting thing that has to sit inside a service model. Now this is the classic example of service composition. Service composition is a big word. It's used a lot. It's a very important concept. And the idea is that you create complex functionality by composing simpler functionality, putting together simpler functionality. So the classic example is travel agent service. So a travel agent offers a service. It's an end-to-end service. I'll book the whole tour for you. And it's actually a composition of a bunch of lower level services. There is a service for airline ticket booking. There is a service for hotel booking. There is a service for airport transfer booking. There is a service for tour booking, for theater booking, and so on and so forth. And the ultimate travel agent service is a composition of these component services. So these are composed together to create the larger service. So this is something that has caught the attention of both industry and the research community a lot. So there's a lot of stuff going on, but I think sometimes I joke with my research colleagues that probably more papers have been written about composition than actual compositions done. So there's a lot of research on this topic as well. So the composition idea is that you take services and put them together to get a larger piece of functionality. So
we can talk in terms of abstraction when you say about composition. Because you'll be abstracting when you're...
Yeah, yes, in some sense, and this slide exactly shows you that, right? So I have, let's say I have available to me the airline service, the hotel service, the tour service, and so on and so forth, right? Now I have a requirement given to me, a functional requirement which says, and I made it very simple here. The requirement is written in a logical form by saying the air ticket must be booked, and the airport transfer must be booked, and the hotel must be booked, and, right? So this is the functional requirement. And I have a non-functional requirement also. So the sigma, the summation of all the costs must be less than my budget, and the summation of the times, the deadlines for each of these things must be earlier than my final deadline. Now any composition which satisfies the functional requirement and the non-functional requirements is a valid composition for my purposes. So I do two kinds of checking, right? I check to make sure that the composition delivers the functionality, and I check to make sure that the non-functional requirements are met. So checking the functionality, right? So in this case it's trivial. I have a service which gives me the outcome that air ticket is booked. I have a service which gives me the outcome that hotel is booked, and so on. So I get the outcomes I require. Now I have to check the cost of each service, right? So I have to add up the costs of each of these and make sure that these add up to be something less than my budget. And the times also I have to check in a similar fashion. So this is it's a very complex story with service composition, but in very simple terms, this is it. This is service composition. You have a bunch of component services and you want to put them together in ways that delivers the requirements you have. So now the question is, how do we model service compositions, right? So the first things to ask is, BPMN, as we saw it, was like a service composition language. Why? Because if you look at one of these things, each of those tasks or activities is like a service. And that's a composition model, right? It says first I will do this service, then I'll do that service, and so on, so on, so on. So it's a composition model. So if that is the case, can I check if, for example, this service composition meets my functional and non-functional requirements? Can I check? So now let's look at this. In the previous example with the travel booking, right? When I said that I had a condition air ticket booked, this was the post condition of this service, airline ticket booking, right? So I had access to a post condition. I knew that if I executed this service, that condition would be true. I would have an airline ticket booked. In this process model in BPMN, do I have a post condition for this guy? No, right? Do I have a post condition for this guy? No. So what's missing in BPMN is this whole idea of post conditions, right? I don't know what the effects of these tasks are. What I see inside each box is a procedure name. So post conditions are missing, right? For these tasks in BPMN, I don't have the post conditions. If I did, then I could at least answer the question, okay, if I put them together in this composition model, then yes, I will meet my requirements, or no, I won't meet my requirements. I could do that. But now, I can't. Also, of course, I don't have any information about the non-functional features of these things. The cost of doing each task, the time taken to do each task, all the other features, right? I don't have any of that. If I had those things, then I could also check for the non-functional requirements, which I can't now. So that tells us that, if I wanted to use BPMN as a service composition model, and ideally I should be using it because it's a very effective language in which I can talk about how component functionalities are stitched together to get a larger functionality.
But then you're just stitching the processes, right? You're not stitching the causes and effects of it.
So the effects are missing, but I'm stitching together services, right?
Isn't that the whole reason you have BSRL?
So that is the interesting thing. Think about it like this. We are going to that debate I was telling you the story about, where these guys from different companies spent an hour of my tutorials time going through what's the service, what's the process. So for now, think about a BSRL description as a wrapper around the whole thing. Right? So it gives me an overall story about what's happening, with what precondition, what post, what input, what output. And this is the detail, this is what's inside the black box. Or I can say each BSRL description describes one of these boxes. You could think of it like that as well. If I had that, then my problem is solved. But if I don't have that, if I just have what is in a BPMN model, then I have a problem. Right? So now we are then asking the question that to be able to do service composition reasoning, we need a layer on top of BPMN. Right? So let's see what that layer should look like. So now I'm going to move on. Finally, by the way, I finished what I thought was my first lecture slides. This is it. Now we are starting the second lecture. Right? So this is what I've now got a very modest plan for what is going to be the second lecture. I don't have a long list of dot points now. So we saw this little example earlier, right? How does a doctor think of a process? A doctor doesn't think of a process as a sequence of procedures, right? A doctor doesn't say, I'll give this pill and then that pill and that pill. Doctor says, I will lower blood pressure, I will lower blood sugar, and so on, right? Doctor thinks in terms of the effects, the post conditions to be achieved in the patient, right? So doctors thinking in terms of post conditions, but BPMN is forcing us to write in terms of procedure names. So there is a mismatch. But there's also something interesting we did once, which was look at the problem of clinical interactions. So this is a big problem in hospitals where you have patients with multiple diseases. And this is very common for elderly patients especially. So the patient has one disease and another disease and another disease. And sometimes these diseases are being treated by different specialties. So you get one specialty come to treat one disease, another specialist coming to treat another disease. So we are asking the question, can we check if there are any negative interactions between the clinical processes being applied for treating each disease on the same patient? So one of my oncologist colleagues gave us this example. So suppose this is a male patient who is suffering from kidney failure. So this person is being given dialysis and so on and so forth. And actually not uncommon, right? Elderly male patient with kidney failure, but at the same time, this elderly male patient is suffering from prostate cancer. So the person is also being treated for this kind of cancer. Now it so happens that the clinical protocol, the guideline for treating patients on dialysis is that they give the patient a pill which is like a male hormone. So dialysis reduces the level of male hormones in the body, so they give a pill to increase the level of male hormones, androgens. On the other hand, for prostate cancer treatment, they routinely give a pill to lower the level of androgens in the body. Now remember, a nephrologist is treating the patient for the kidney stuff and the oncologist treating the prostate cancer. Different specialties, different specialists, they come at different times, they don't talk to each other. They're not checking that these two guidelines are actually going to negatively interact. On the one hand, they're trying to raise the level of androgens, on the other hand, they're trying to lower the level of androgens. So how do you check? So there's a computational solution, right? The computational solution is model the processes, model the post conditions of each task. And if you did that, and we showed that in a paper, that if you did that, then you can actually say, okay, I have one post condition which says increase androgen, another post condition which says lower androgen. These two are inconsistent, we have a problem. Right? So this is what we want to achieve. So there are some counter arguments that were offered. So people said, why can't I pre-compute these? So for every guideline, I check how it interacts with other guidelines, and I have a complete list of these, and so I know which two guidelines I should not apply at the same time on the same patient. Now think about it. The National Institutes of Health Guidelines Repository, guidelines.gov, talks about 18,000 different diseases. Actually, there can be many more, right? The ontology.
It's a big number.
18,000. NC1, NC2, NC3 combinations.
Yeah, 2 raised to the power 8,000.
It's not about 18,000, it's 2,485.
Yeah, but then still.
So now think about it. 18,000 choose 1, plus 18,000 choose 2, right? Up to 18,000 choose 18,000. So think about the exponential space there. So you have to pre-compute all of these. So you don't do it, right? So you don't do it. Yeah. Actually, there's a very interesting other story with regard to the 18,000, if you're interested. So, in medicine, right, the medical ontology is actually a really important thing, because how a doctor classifies you, the patient, is ultimately the main determinant for how you are treated. Right? So, if you think about the treatment of cancer, I mean, I've read a lot of histories of the treatment of cancer. So they say that earlier people used to classify a cancer by attaching it to the organ where it is found. So you see a cancer in the brain, so you say brain cancer. But maybe the cancer didn't start in the brain. It started somewhere else. It ended up in the brain, right? So they had a very coarse-grained classification scheme for cancers, indeed for other diseases. Later on, they said, okay, actually there was a very interesting story. There was a man called Halsted, William Henry Halsted, who was a very famous pioneer in the late 1800s. He invented this surgical procedure called radical mastectomy, removal of breast for breast cancer and so on. He's very famous for those reasons. He was also a data scientist. He collected detailed data for all his patients. And he used to ask the question that, he started by taking out part of the organ, right? And he said, okay, some of my patients get better and some of them don't. So he said, okay, let's be more aggressive. Let's take out more. In the end, he invented radical mastectomy, which was literally taking out he stopped at the rib cage. He was almost going to take off the rib cage. So he was desperately cutting out more tissue in the hope that that would cure. But then he kept seeing in his statistics, he was a careful data scientist, he kept his data. He found that no matter how much he took out, some patients lived and some patients died. So he could not figure out why. And then ontologies came to play again. You know how? They said, okay, so what we are missing now is the stage of the cancer. So if it's a stage 4 cancer, no matter how much you take out, the chances are that the person will not have a good outcome. Stage 1 cancer, you take out even a little bit, it's pretty good. The person will probably live. So there was this additional classification hierarchy that was imposed now, which said the stage of the cancer. Now there is a much more complex scheme called the TNM classification scheme that is used. Tumor node metastasis. So they classify cancers in that scheme. So it's very interesting. The idea of the vocabulary with which a disease is classified makes all the difference to what treatment a patient receives, because basically the classification category comes with a treatment protocol, right? So if you're classified correctly, you get the right treatment. People are talking about personalized medicine. What does that mean? That every individual patient is a separate category. So you are a category in your own self. So whatever is going to be designed will be custom designed for you, which is a very interesting story in its own right, because you cannot have this guidelines-driven, process-driven practice of medicine and then say you're doing personalized medicine. I always ask my oncologist colleagues, how can you say these two things? Because one, you're saying that for your disease there is a guideline, I will apply it no matter what, and then you're saying I'm going to make it personalized for you. How can these two things live together? Right. Okay, so for these reasons, again, we are going back to the idea that we need some extra, the post conditions on tasks in process designs, right? So that's what we are interested in doing. So if you look at a process model in BPMN, what kind of state, so we answered this question, right? So what notion of state can you have? You can either, if you ask a question that I've done this much in a process, what state am I in? You can say, okay, I'm in a state where I finished doing task T1. Or you can say, I'm in a state where I finished doing task T1, followed by T2, followed by T3. This is your notion of state in a process model, right? That's not very interesting, right? So what state am I going to be in when I have got to this point? You answer by saying you've done T1, T2, T3. That's really not interesting as an answer for me. So I need something more. So it's interesting. If my process model is described at the lowest level of granularity, remember yesterday I was saying that, at the lowest level, all processes are really reads writes, right? So there's nothing else. At the lowest level, all computation is just reading something, writing something. Think of a Turing machine, right? All you're doing is reading, writing. So if you're describing processes at that level, then of course there's nothing else. This is just, you don't need to get into this business of talking about post conditions because it's not very interesting. I mean, what is the post condition? What is the effect that you achieve after doing a write? What do you say? Well, I've done a write. What is the effect of doing a read? You've done a read. There's nothing more interesting to say. So these post conditions are interesting when you're talking about abstract tasks. Lowest level atomic tasks are really not interesting from the perspective of writing post conditions. So we're really talking about processes where there's some level of abstraction involved. So a lot of the business process management literature, and it's very, very busy, as you know, it's a large body of work, a lot of people working on it. There's a lot of activity, particularly in Europe, because of companies like SAP and so on, where their product is really business process tools. So huge amount of work going on. So a lot of this research says, okay, so all we have available is a BPMN model. So if I want to understand, for example, how similar two tasks are, the only thing I can go by is the name of the task. So it's like saying if I want to understand how similar two procedures are, the only thing I have access to is the name of the procedure. So in fact, there are papers that say, check the string edit distance, the difference between the two strings, the names of the procedures. And that tells you how different they are. That's very dangerous, right? I can write very, very different procedures with very similar names. I'm sure you can give me lots of examples. So just having similarity in names or dissimilarity in names says nothing about what they're doing. And yet this whole community for a long, long time, and even now to some extent, they're saying that's all we have, just the name of the procedure. That's all we can work with. So now the argument is that we want to instead say that the procedure name is one thing, but we want to also get some additional detail. What is actually happening? What are the effects achieved by doing this task? So some people are using ontologies, right? So these concept hierarchies, and they're saying, okay, I will describe what is the effect of doing this task by making reference to some concepts. But they're doing this in a way that makes it very hard. So if you are a business analyst who is trying to describe post conditions, you have to take every process model in BPMN, and they're large and complex, and for every task you have to describe the effects of the task. So there's a lot of work involved. What we were trying to do, and I'll tell you the technique that I think is quite effective, is we said, suppose we only wrote down the tasks, post conditions in a context independent fashion somewhere. So for example, if the task is switch on a light, flick a switch on, then its context independent post condition is that some circuit is completed. Right? Then, based on the context where I park this task, the actual context dependent effect will be made available. So if I now put this task inside a process which makes reference to a circuit that involves a light bulb, then when I do the task of flicking the switch, the effect, the immediate effect is that the circuit is completed. The cumulative effect is that the light bulb comes on. But if I take the same task and park it in a process which involves a circuit that controls a nuclear reactor, then the immediate effect of the task is still a circuit is completed, but the cumulative effect now is the nuclear reactor comes alive. Right? So the context now determines the real effects of post conditions I'm going to achieve by doing certain tasks. So this is very interesting, right? So we now can, if we can do this, because this makes life very much easier. So I'll give you an example of how complex this gets. So this is a clinical process model for the treatment of head injury. So there's a lot of medical detail in there, but you can see it. Now you ask a doctor, what are the real effects, the post conditions of doing each of these tasks? You'll get something like this. That's one task. And those are its effects. Right? So there's a lot of detail. So just doing the one thing leads to so many different state changes in so many different objects. So now observe what I just said. State changes in objects. So the effects of post conditions are really what I'm talking about is a set of objects that are impacted by this activity, and the impact is via some state change. Each of these objects was in some previous state, and after the activity is done, it is in some next state. So for example, if I just look at this one, the object, the cervical spine of the patient, previously it was not immobilized, now it is immobilized, right? It is a state change. So if I think of a patient's body as composed of lots of different objects, many of these objects go through state changes because of the execution of one little clinical activity. So you can see that there's a lot of extra information that I can put into this story by writing that second column, right? And so there is some value in doing that. And what I will argue then is that that value also allows us to think of this BPMN plus model, which is BPMN plus these effects. It allows us to think of BPMN as a service composition model. It allows us to now ask the question, does this process meet my requirements? Does this process achieve my goals? Right? All of these questions can be answered if I have access to this stuff. So we built a tool which essentially allowed you to answer this question. So you could literally take a BPMN process model and you'd take your cursor here and you'd click and you'd get an answer to this question. What would the effects of this process be if I got up to this point? Right? So we had a tool called Process here which did that. But the biggest challenge, so we had this for many years and we were trying to get people excited about this tool. Biggest challenge we faced was people would say, who's going to write this stuff? So we still need somebody to write it, right? To write the context independent effects or post conditions of each task. Who's going to write it? Business analysts are, you know, they have a hard time drawing one of these pictures in the first place. And then you say write logic or something, write down these effects. It's very, very hard. It's difficult to expect them to do these things. But as of the last 2.5 years, I can say confidently, you don't have to write it. We now have a data analytics technique which learns it. So we learn the post conditions of these tasks from execution data, historical execution data. This is a very powerful thing because there is a large body of work on process mining which takes historical execution data and learns things like BPMN models from the data. So that's not my work, that's other people's work. It's been going on for about 15 years. Our more recent work in the last 2-3 years takes similar data and learns these post conditions from the data. So now people who say, your stuff will not really work because who's going to write that stuff, I'll say nobody has to write it. We'll learn it. So this is data science in action. This is good stuff, right? You can shut people up. With a little warning, right? What the data mining learns is not always perfect. It's pretty good, and for the papers that we've written, we found reasonably good results, but not perfect. So the intent again is that this is like a first cut. The data mining learns for you the first cut post conditions, but then some analyst sits and edits it and says, okay, this one's good, this one's bad, remove it. So, but that's still better than writing it from scratch. So now instead of model building, they're doing model editing. Right? So that's a definite improvement over building models on a blank sheet of paper. So, okay, so I think we're almost at the last 3 minutes of the lecture. Ask me some hard questions. So what I will do next is give you a sense of how this effect annotation of process task can be done. I think that's really important. If I did nothing else but gave you a sense of how that is done, you'd get a real insight. And it's a funny thing, I teach this class every year, second semester at my university. What students say in the end is that if nothing else by doing that, we had a real understanding of the meaning of these process models. By doing this, you get a very clear understanding of. So remember what I was saying the other day, that there is depths of complexity in flowcharts even. So you'll find out what that complexity is by doing this. So I'll talk about that, and I'll also talk about how you can use data analytics techniques to learn these things, which is a really simple idea actually. And so remember then what we have ahead of us is a little bit of, we have only 3 lectures left, right? Do you want to give up your lives for the cause of science? We can stay here all night and finish all the material. I won't force you to do that. We'll do what we can in the next 3 lectures. Are you getting useful stuff from this, from all these things I'm saying? Yes? Yes? Some nodding heads. The movie camera is on you now. And this is where you get the background music. This, the moment of truth. Some people are going to say no. There's a no guy sitting there in a reddish pinkish t-shirt. Are you a no or a yes? Yes? What are you getting from this class? Okay, he's getting embarrassed now. So hard questions? Any question but the meaning of life? Anything else? If you don't have hard questions, you're not getting it, right? There are a lot of Asian countries where I go to give talks, and then at the end of the talk it's total silence, which is often not the case in other places. Other places you get lots of questions. Most Indian audiences are very aggressive with questions, which I like. You guys are not so aggressive. You should be more aggressive. But in Asian countries, East Asian countries, right? So totally quiet audience. And then I asked my host, what did I do? Did I really give a bad, boring talk or what? Why are they so quiet? And I'm told that, they're being polite. Cultural thing. There's asking a question is like, slapping you in the face. So they don't want to do it. They think they're going to insult you if they ask you a question. And I try to tell all my audiences at the beginning when I give these talks, please ask questions. It is not an insult. It is a compliment. It is a reward. Every question that you ask is value for me. Right? And the harder the question, the greater the value for me. The best questions are the ones that I cannot answer. I stop and I say, okay, I really don't know. That's a very good question. Those are the very best questions. That's where I get max value. Some of the best conferences in computer science, you see some of the top researchers debate, and it's lovely to see that. I once saw, so in artificial intelligence, there are two competing ways of representing uncertain knowledge. One is probabilistic, and the other uses fuzzy set theory or fuzzy logic. So the two top people in these two areas. So the fuzzy logic guys, the two of them, Dubois and Prat, they're both Frenchmen, they were presenting, and the top probabilistic reasoning person, his name is Jodiah Pearl. You might have heard of his son whose life a movie was made. He was a New York Times reporter who got killed by terrorists. Anyway, so Daniel Pearl. So this guy stood at the back of the audience and he debated loud and not polite at all. Not at all polite. He was basically yelling at them and saying, what you're saying is rubbish. And these guys were defending themselves, saying, no, it's not rubbish, it's good. And he said, no, I think it's rubbish for these reasons. And we were like watching a tennis match, this way, that way. Right? You're going back and forth. It was lovely. It was really an experience. A good debate, there's nothing like a good debate. So get into that habit of engaging in debates, and remember, you're showing the speaker a lot of respect if you ask a question. And there is no such thing as a stupid question. There is really no such thing as... There are some very famous researchers who, and I've seen them in conferences, they sit in the back, right? And then I'm giving a talk and I see this famous guy, and the guy's got his head down and he's snoring. I said, oh boy, my talk must be really bad because this guy is sleeping through my talk. Right? So the guy is snoring, and I finish my 25-minute talk, question time. Suddenly the guy wakes up, hand goes up, and asks me the most brilliant question. I said, what? How did that happen? Wasn't he sleeping throughout my talk? But he had a really good question at the end of it. And then, of course, I feel good because this guy took my stuff seriously. So remember, this is part of the dynamic of interaction in these kinds of academic communities. So this idea of sitting quietly at the back is a bad idea. Okay, enough said. See you tomorrow.